So this is a fourth part of sentiment review analysis. So in this part, we are going to use a pre-trained model, which is a BERT model. So ideally, what we are doing here is we are not defining any model. Instead, we are taking a pre-trained model called BERT, which is already trained with a big, huge English corpus, right? So it's kind of an English language model. It knows everything about the English language. Now we are using this model, right? And then on top of that, we are just converting our input data, which is our YELP review, into BERT-based embedding vector, and then we are sending that into a BERT model, and we are predicting the results. Ideally, we are not creating any model here. So all we are doing here is we are using it. So you can see here I'm using a transformer. So a transformer from the Hugging Face library. So in this we are using BERT tokenizer, which is to convert input data, which is in text format now, is converted into BERT based tokenizer. Earlier we just created a word bank in which we have 5,000 words, whereas here in this we are using a BERT tokenizer. The BERT brace embedding will be done. So here we are not just assigning a number. Instead, we are contextually converting each text into a vector. So for that, and so you can see that here. So BERT tokenized, we are using this model. And also we are defining a BERT model, which is again the same model. So here I mentioned number of labels is 5. So you can also mention the number of labels as 2. It's up to us, right? So whatever the data we need, we can mention it here, right? So now we are going to mention it 2 because we have 2 class here, right? And then our input data. So we have 2 data, trained and test data, right? So I'm converting trained data, right? So I'm converting trained data into vector here and corresponding attention marks. So these are required for encoding, and then we have our Y train. Also, so we are converting a test input or called as a validation data set into a vectors here. Okay. So for the first time, it loads all this model, right? And then, meanwhile, it loads, you can see that here. So we are using the same accuracy as a matrix, and then we are kind of training the model with this input data. So though we already taken a pre-trained model, we are just adding a final layer of our own data set. So it's a kind of it's a kind of custom fine tuning where we are just appending our data set on top of the existing data, right? And then we are training our model, right? We are training our model. Then we are going to do the same thing, evaluating with the test data set and then predicting with real-time data. Right? So here you can see the models are downloaded and then it is converted into test and into a proper vectors, both trained data and test data. And you can see that here we are using a Hugging Face stuff. So we are compiling our model and this is our model. So in the previous model, we close to have 800 thousands, and here you can see the number of parameters, because this is a huge model. Now we are training for one epochs. So this epoch, uh, this is already a pre-trained model. So one of it's again less than 20 is very much enough for this model. So close to 15 or 20 epochs are pretty much enough. So we are training with one epoch, right? And then we'll see the accuracy. For that previous RNN model, we got accuracy of 79% after iterations of 10. Right, 10 epochs, we got 79%. So after training one epoch, we got accuracy of 74.65%. But you can take it took almost 900 seconds to finish the training. But for one epoch, we got a 76 percentage as 75% as the accuracy. For RNN, we train for 10 to reach 79%. Anyway, now we will evaluate this model based on a test data set for this one particular epoch. The same, we are generating a confusion matrix and then we are calculating all the recall and precision F1 score for this model. So we have taken same 80-20. The only difference from the RNN is we tokenized our model based on BERT tokenizer, where we converted text into vector based on the BERT model. So the BERT is an encoder. The ultimate performance booster is a BERT tokenizer because it is converting text into vector based on contextual understanding. So for each word, it knows what is the meaning and what is the relevant other words. So based on that, it is converting into vectors. Now we are evaluating its performance using our test data or validation data. So it is a 20% of our actual YELP data set. So you can see it's we got for our validation data set, we got our 80% of accuracy. See, only one epoch, we got 80% accuracy, and you can also see these diagonal values. So this is 74, that's 172. So we are having a better results using BERT even for one epoch. Then imagine if we train for the 10 epochs, then you can easily get better accuracy. It's close to 90%. We are going to prove the same test with the real-time data. Again, we are doing same process, converting our text data into tokenizer, and then we are calculating the results of this data. So positive and negative. Okay, so let's print the confidence score here. So the confidence score is not a direct values here. So instead it is giving some other values. Okay, so this one is negative, so you can see this is high value, and for this it's a positive. You can see these are higher values. Right? Thank you.